Hello, in this lesson, we're going to talk about decomposition. Okay, we have done so much composition, right? What are the compositions have we done? Okay, the composition. For example, for any one-to-one function, okay, for any one-to-one function, f, and its inverse, right? F inverse. And we know that we have that very useful properties, right? One's domain is the other's range. And we also have that composition of these two functions, which equals to x, if x is from the domain of f inverse. We are pretty familiar with it. These are called composition. That's a composition of two functions. And of course, prior to that, we have more general form. Okay, we'll get to the more general form. So we just got, right now, we just look at all the composition we have done. Okay, all the composition we have done. And decomposition is the opposite of it. Okay, the opposite of composition. So now let's see the other property. So even in this line of composition, right, we have done so much between sine, arcsine, cosine, arccosine, tangent, arctangent, cotangent, and arccotangent, and the miscellaneous kind of composition, which we saw in the previous lessons. And here, this x is going to be in the domain of f, right? So these are the examples of composition. So these are the case now. Example number one, right? What we have done are such as, right? Such examples such as for sine, arcsine, right? So we've done these, sine, arcsine. Okay, so I'm going to gradually introduce you to these notations. Okay, this is the same as arcsine. This is the same as arcsine. It's written this way, you know, in recent, you know, in the past decades, it has become more and more popular. Okay, so arcsine. This is read as arcsine. Arcsine. Okay, so we have seen these compositions. Say arcsine. You can still use arcsine for sure. Okay, and sine, things like that, right? And we see similar things such as for cosine, right? So this could be cosine. All of these are compositions, and we have lots of these, right? So let me just show you what we have done. Okay, cosine of something, and sometimes it could be a number here, right? It could be a number here. Those are compositions as well. Okay, and tangent and arctangent. Okay, and arctangent of tangent of something. So all of these are examples of composition. Okay, and these are in the form of F composite G, F composite G, F composite G, or function. And we are certainly very familiar with this form, right? This is the general form, and these are the examples. These are the examples. And in the last, in the recent lessons, we also have things like these. Okay, arc tangent. Right, so all of these are compositions. Okay, all of these are compositions. So the general form of composition is such. Okay, the general form of composition is, okay, F composite G. And how does it work? How does it work? Right? How does it work? In our previous example, we know that, say, take the example of sine, of arc sine, right? In this case, how does it work, right? So you see, how does it work, right? There's a flow, okay? There's a flow for this process. In the case of sine of arc sine, this is how it works. We have input. The input is x, right? Since arc sine works on it first, right? Since arc sine works on it first, this x has to be from the domain. This x has to be from the domain of arc sine. Okay, which is, what is the domain of arc sine? And of course, that's -1, +1. It produces an angle, okay, produces an angle, and this angle is going to be in the range. It's going to be in the range of arc sine. Okay, so this is going to be in the range of arc sine. And so this output after this function, right? So this is an angle, and this angle will be the input for the next function sine. So it will be for the next function sine. Right there. Okay, sine. So this angle as the input is going to give it to sine, and eventually it produces a ratio. It produces a ratio. Okay, so that is the flow. That is the flow. And so that's just one of the examples. Okay, for the flow. So how about F composite G in general? F composite G in general, of course, it also has a flow. And this flow, you can see it goes like this. Okay, so first you have an input. And this input is going to be in the domain of G. Domain of G. Whatever it is. Okay, whatever it is, it's going to be in the domain of G. And then this input will be applied the rule of G. This input will be applied the rule of G. And after G, rule of G, function G is applied to the input, it produces a G of X. Okay, G of X. If G of X, and usually it is the case, G of X is going to be in the range of G, okay, in the range of G, and at the same time, it's also And it is also in the domain of F. Okay, so this output is in the range of G for sure, but it is also in the domain of F. And that's how we're going to apply the rule of function F, okay, to this input for this G of X. So G of X as the output from the first round, we're going to take this and use it as input for F. So it produces eventually F of G of X. So this is the flow. This is the flow. Okay, this idea actually is used in computer science. And so you can call the functions and you call routines or whatever you do to process whatever information you need to process. So that's F composite G. That's F composite G. Okay, so with that said and done, so let's look at what is decomposition, right? We have done plenty of composition. So what is decomposition? Decomposition basically is going backwards. It's going backwards. Okay, so this process is going backwards. For example, suppose I have a function which is e to the power of sine x. Okay, e to the power of sine x. Okay, this function may look very strange to you, but it is indeed a function. Well, this function can be viewed as a composition of two functions, So when we decompose it, okay, we have two functions. One is the function of f. We're going to call it e to the power x. And the other function, we're going to call it g, and which is going to be sine x. Okay, let's see how we can get e to the power sine x from f and g. Okay, now we're going to do f composite g of x equals to f of g of x and f of g is sine, so sine x. So then we apply the rule of f, which is going to end up to be e to the power of sine x. Okay, you see that decomposition? So the question is, how do we do decomposition? How to do decomposition, right? You can see this function actually is a result of a composition of two basic functions. The topics of decomposition actually is not very much covered in a lot of the textbooks I've seen. So I wish you guys to pay attention to these concepts, because decomposition as a topic is very, very useful, very, very important, and you're going to need that in Calculus 1 and other courses that are coming your way. So how do we do decomposition, right? You can see the way I have done the decomposition is that we're going from outside inside. We're going to go from outside inside. So when we do composition, we're going to do from inside out. Okay, you see, this is the inside out, right? We're from the inside is G. The inside is G. So when we do composition, is from inside out. Okay, so from inside out, that's composition. Decomposition, okay, decomposition is from outside in. So let's write these down. Okay, so for composition, okay, for composition, we're doing from inside out. Decomposition is outside in. It's just the opposite. For example, how did I compose this function? Right? How did I decompose this function so that this will work? Right? So what I did basically is that I'm going to assume, okay, I'm going to go from the outside. From the outside, I see this is just e to the power of a bologna. And what is my bologna? My bologna or omega is sine x. Okay, so this is the outside and that's the inside. You see, from outside in. Okay, so you can see e to the power of something. I just overlook whatever it is. Okay, I know e to the power of something is going to be a simple form. And omega is the sine function. So this way, from outside in, I get the decomposed form of the two functions. And sometimes it could be 3, 4, 5 of these functions, and they're all very similar. So first we're going to do 2 layers. We're going to do 2 layers. So once you have set up these, right, and you can safely say the outside function is going to be e to the power x. Okay, if you want to call it bologna, you can do that. You can use bologna for sure. Okay, you can use bologna for sure if you want. Okay, it makes no difference because it just, the omega is just a placeholder. Okay, the next layer, right, is the omega is going to be equal to sine x. And you can totally make this a new function. So f of x, okay, so in general, we write it in this form. So it's decomposed. Decomposed. So composition, inside out, decomposition, outside in. Okay, so let's look at some examples. Let's look at some examples of decomposition. Decomposition. Okay, I'm going to give you some examples of decomposition. Okay, knowing the basic functions as we have discussed. Okay, knowing the basic functions we have discussed. So let's look at the basic functions. Let's look at the basic functions. Okay, basic functions. So what are the basic functions we have studied? Right? So let's take a look. What are these basic functions? We have all of these, right? All of these are basic functions, aren't they? They are basic functions. And these are basic functions. Hold on. And these are basic functions, right? These are basic functions. And that's basic functions, right? If we keep going, we have reviewed these. And 2 to the power x log base 2x, these are basic functions, right? 3 to the power x log base 3x, those are basic functions. And next, of course, comes to e to the power x, that's the basic functions. And keep going, we get to the trig functions, right? All of these are basic functions. All of these are basic functions. So with that as our basic functions, when we decompose, right? So let's have this, hold on, decompose, okay, into basic functions, okay? Decompose into basic functions. So let me give you some examples. Okay, let me give you some examples. For example, you have a power 1 plus x squared to the power of 23. How do we decompose that into simpler functions? If we expand this, is it going to be a total? It's going to be very complicated. It's going to be very complicated. Okay, so how do we decompose it so that it's being treated as two simple functions? Okay, so how do we decompose it? Decompose these functions so it's treated as a, just simple functions. And these techniques is much needed for your calculus classes, So this is how we do that. Okay, this is going to be how we do that. Okay, we're going to treat this as something to the power, Okay, something to the power. So that's a function. Okay, so this is my f function. Okay, and my next function is that this piece that was there before is the other function. Okay, so this is g of x. So my f is x raised to the power 23. My g is 1 plus x, so 1 plus x squared. And this function is simple enough, and this function is simple enough. Okay, so here we go. And you can test it, test drive it, right? So we're going from outside in. When we test drive it, we test drive f composite G. It's going to be f composite G. Well, then you say, what if it doesn't work? It doesn't work, you try again, right? You try again. So f composite G, G is 1 plus x squared. Okay, and f of 1 plus x squared. So now we're gonna bring this rule inside to our application. When that rule is in our application, we basically take the input and power by 23. So we take the input and power by 23. That's it. It works. It works. You can see we do it from outside in. Okay, we do it from outside in. So let's look at, I'm going to give you another example. Okay. Decomposition. Wait a second. Where's my, I just found that page. Oh, here it is. Okay, so let's look at another one. Okay. So this is example number 1. Let's make this example number 2. Okay, so we have a cubic root of 1 plus 4x. How we decompose it? Compose it into simple functions, right? Compose it into simple functions. So what do? We do it from outside in. Okay, so from the outside, I see cubic root of something. So I'm going to make this something to be omega. Okay, and omega, is that piece. Okay, so if I make a function out of the first one, which is a cubic root of a number. That's the rule. And the next function, of course, is g. And here we go. Okay, and we can test drive it. We can test drive it. Okay, so here we decompose. Okay, we decompose that and we test drive it, right? So the function outside, F composite G, we're testing it. So F composite G of X equals to F, right? G is 1 plus 4X. And that's the rule. And what's the rule for F? F basically takes whatever input and power and take a third root. And this is the input now. Okay. So according to the rule of F, it's going to be root 3 of that input. Okay. Let's look at the next one. Okay. Example number 3. And here we have 10 pi times x. And we want to decompose it to simpler form. Tangent pi times x. Okay, so decompose that. Let me put a dash in between. I don't know, do we have these words? I don't think we have this word in math, not yet. Okay, because this technique is rarely taught. It's rarely taught. When I was taking calculus class all those many years ago, you've been thrown into the water, swim or float. Okay, swim or float. Then you gradually figure out, oh, I need to peel it off or decompose it layer by layer. Okay. So to decompose tangent pi x, right? So I'm going to take this function. I'm going to see whatever after tangent, that's the input. Okay, so that's my input. So that input, I'm going to see it as simple form. And that, whoops. Okay, so that simple form, omega, is going to be pi times x. So but you see, basically we see 10, we treat this as one entity and then separate them if needed. So here we go. Our f of x is going to be tangent x. Our g of x is going to be pi times x. Okay, and test drive it. Okay, so we're going to do F composite G. Right, F composite G, what do we get? F of G is pi x, right? Pi times x. And pi x is the input for 10. So we just take that input and have 10 apply to that input. That's it. You can see it works, right? I'm going to give you a couple of examples, a couple more examples. Okay, so you may like to pause and try it on your own, and try on your own. Okay, so look at this one. We're going to decompose a function, okay, which is sine of cotangent x. Cotangent x. Okay, cotangents domain is x cannot be multiples of pi, right? And the range, which is cotangent, is all real numbers. So sine of any real number, that's well-defined. It's well-defined, okay? So now, what do we do with that? I think you guessed it, okay? So maybe you like to pause it, pause the recording and try it on. Okay, suppose you have tried, you're coming back. Okay, so I look at this and I'm going to make this to be my omega. Okay, and then my omega is going to be cotangent x. Okay, so if I introduce f of x equals to sine of x and g of x equals to cotangent of x, and we will make it. Okay, so let's test drive it. Let's test drive it. Okay, composite. Okay, f composite G. Okay, and will that produce the function we're given? Right, so let's try it. Try it. So that's equals to f of G is a cotangent, right? Cotangent, and f is a function, which is a sine function. Sine function just takes whatever the input and apply the rule of sine. So we apply the rule of sine to cotangent. Cotangent output is the input for sine. So here we go, it works. Okay, so here I'm going to give you a couple more examples all at once. All at once. Okay, so try it. You may like to pause it and try it. Okay, so the first one would be e to the power of square root of x. And the next one is the square root of 2 minus e to the power x. So how do we decompose that? And the next one is ln x squared minus 2x. Okay, so you may like to pause it and come back. All right, I assume you guys are back. Okay, you have tried. You have tried. So for this first one, I would make f of x to be e to the power x, and the next function g would be square root of x. Okay, and if we test drive it, we have f composite G of x, and that's going to be f of G of x, right? So that's going to be e. Let's do it from inside out. So when we compose, we do inside out. So this is square root of x. That's for G. When we do f, the rule of f is take that input, okay, and power e. So we have e to the power of square root of x. There, it works, right? And make this example number 6. I think by this time you got the hang of it. You got the hang of it. Okay, so decomposition from outside in. from outside in, okay? So if we look at the whole, it's a square root of something, okay? So the outside is the square root. Okay, the square root of x. And inside the square root is 2 minus e to the power x. Okay. And then f composite G, we'll get it. Okay, f composite G. So it's going to be f of G. G is 2 minus e to the power x. And then for f, for the rule of f, is just a square root, right? Whatever the input, it's a square root of whatever the input is. And example number 7. Okay, decompose. Oops. Decompose. So how do we decompose it, right? Obviously, from the outside, we see ln. So the outside function will be f of x equals to ln x. The inside function is g of x, which is going to be x squared minus 2x. Okay, actually 3 more examples. Okay, number 8, we have, we're gonna do a comparative study. Okay, example 8 and example number 9. Example 8, we are going to decompose this function, cosine x to the power 2. And the next one is also decompose, is a cosine squared of x. Okay, I put these examples out of calculus textbook. Actually, most of these examples in your homework, they're from calculus text. Okay, so let's look at this one. Okay, first we have to understand the order of operation. First of all, what does this mean? This means cosine of x times x. And this other one means cosine of x squared, which means is a cosine x multiply itself. You can see these two functions are very different. So when you see what's inside, what's outside, it's going to be, you're going to have to see it from that perspective. So the first one would be the f is going to be cosine x. The g is going to be, oops. We could use z if you want, okay? It would just be x squared, okay? And the other one, however, because you see something being squared, so the f is actually going to be x squared, and the g is going to be cosine x, okay? So let's test drive it. Let's test drive these two processes, okay? F composite G equals to, okay, F of G of X. All right, so F of G is X squared. G is X squared. And f of x squared. So this is the input for f. What does F do? F just take whatever input and apply the cosine rule to it. So whatever the input, so now the input is x squared. Therefore, we're gonna apply the rule of cosine. Whoopsie. All right. On the sec, number 9, however, okay, because we see square first, okay, so the outside is f of g of x, okay, which is f composite g, right? The same drill. But you can see because of order of operation, and we have to know how the operation is done. So now f of g, what is g? G is a cosine x. Okay, g is a cosine x. And f takes whatever the input is square the input, right? That's what f is. So therefore, we get the input being squared. And of course, that input is just cosine square x. Okay, these two examples are very telling about the importance of order of operation. So let's look at example number 10. Okay, so we have ln, the absolute value of x. How do we break it? How do we decompose it? How do we decompose this piece? Right? Decompose. Do we have such a word? The first side we see ln, right? So the outside is ln x. The inside, what's the inside? The inside, of course, is absolute value of x. Okay. And of course, we can test drive it. So let's do test driving for the next one. Okay. F composite G equals to F of G of X equals to F of G of X. We do it from inside out because now we're testing drive it, so we're composing. So G of X is absolute value of X, absolute value of X. And then we apply the rule of F. What is the rule of F? Whatever input we have, we're going to apply the natural log rule to it. So it's going to take ln applying to the input. So that's the input. Okay. The next question is, are there many layers? Yes, there are questions, there are issues, you know, there are functions that you have to decompose it into many, many, many layers. Okay. And in this course, we would just mostly do the 2 layers. 2 layers should be sufficient. But looking ahead, I wish to give you an example since I think you got the hang of it. Right? So I would give you an example so you would decompose a much more complicated function. And this example I'm going to borrow. Okay, it's just like most of the homework questions I have given you is actually from the textbook that you're about to use. Calculus textbook. Calculus textbook. Okay, in the section of chain rule. In the section of chain rule. Okay, so you can see that when you apply chain rule, you really have to work it out. You have to work this. Okay, and this example I'm going to give you are from the calculus textbook. Okay, your calculus textbook. And of course, you're going to be performing different tasks but decomposition is part of the story. Okay. It's a foundation for that to be done correctly. So this is the function. Okay, you have a sine squared. And inside is e to the power of sine squared of x. Okay. The next example I'm going to give you is example. It's just to give you a taste about the important applications you're gonna have to deal with. Okay. And this other function is a cosine square root of sine of tan pi x. Let's see how we peel it layer by layer. We peel it by layer. Okay. Whoa, what's going on here, right? Well, we do it from outside in, right? So this expression actually means what? Well, sine of that thing, right? So sine of that piece and the squared, that's what it meant. Okay, so the first layer you're going to deal with, wait, I'm going to remove this f, okay? I'm using the f for something else. So the first layer outside, from outside in, the first layer is going to be x squared. Whoops. Okay, better save it. Okay, the first layer is x squared. And what is g? G is going to be something like this. So we're going to deal with the inside layer. So g of x is going to be this piece, right? But this is too complicated. So we're going to make this, we're going to cut this and make that g of x. H of x is going to be equals to whatever I have taken, which is this piece, right? But that is too complicated. So I'm going to bring this piece and make, that is the function. That's a basic function. Okay, k of x. What would that be? Would I just erased or would I just omitted, right? And sine x, right? What is this? This is too complicated too. So what we do is that knowing this is sine x squared, right? So this function is going to be, the next function is going to be something squared, right? It's going to be something squared. So kx actually is going to be something squared. Okay, so this is something squared, so x squared. So k is the same as f. K is the same as f. Okay, so I'm going to use f again. So finally, I'm going to use k, and k equals to sine x. Composition. So let's test drive it. Test drive the composition. Does it work? So how will this be composed? This will be composed as f, composite G, composite H, composite F again, and compose with G, F, G, H, fk, k of x. Many layers of composition, many layers of composition. So when we compose to test drive if our decomposition is correct, right? If you look at the decomposition, every function is a basic simple function. Every function is a basic simple function. So now what do we have? Right, we're going to do it layer by layer. So this is going to be f of g of h of f of k of x. Whoa. Look at that. So we're going to do it from inside out. We're going to do it from inside out. Okay. Inside, the innermost kx. Kx is sine x, right? Kx is sine x. So this kx will be replaced by sine x. And next, we're going to apply the rule of, what is the rule? The rule of f. What is the rule of f? F is just take whatever input and square it. So now the input is sine x. So we're going to take sine x, right, and square it. So that's the rule of f. Sine is being squared. And sine squared is, we write it this way, right? We write it this way, right? So then h of sine x squared. What is the rule of h? The rule of h is saying take the input, whatever the input, and you're going to power e. So for the rule of for the rule of h, right? For the rule of h, right? The input is sine squared. So h says take that input and power e. So we're going to take this input and apply the rule of h and power e. Okay, then it's g, right? G of something, g of something. So now this is the input for g. This is the input for g. What is this rule of g? G takes the input and apply the sine rule to that input. So inside here, so we're going to take sine rule applied to it. That's the rule of G. Last but not least is that everything you give, any input you give it to F, we're going to just square it. So this piece will be, well, that's the input for F, and that is going to be squared. Okay, and in trigonometry, we know that this squared will be written up here. So that squared is going to be written right there. That's it. Did we go back to where we, yeah, that's exactly what where we were given, was what we were given, right? So that's the decomposition. I hope you get the hang of it, okay? In calculus class, you're gonna need this technique. You need to know, you need to see this, how it's peeled from outside in. So you get each time the simpler function. All right, this is the last one. This is the last one. And this last one, of course, it shouldn't be too hard, right? Sine, f of x now is cosine x, right? G of x is square root of x, right? Square root of x. So you just peel in layer after layer. So this is the square root. The next layer is what? H of x. And that's going to be what? Sine x, right? Sine of tangent, right? So k of x is tangent of x. And finally, let's make a Q of X, right? And that's going to be pi X. How many layers? 1, 2, 3, 4, 5. How many layers we had before? 1, 2, 3, 4, 5. 5 layers. There could be many more layers, but you got the idea, and you can break it. You can decompose them. Okay, there are plenty of examples in the calculus textbook. Okay, so feel free to try them. Okay, but these are the highest level you ever get. Okay, I think I look at these exercises in calculus textbook. I think 5 layer is pretty much the max. So now let's test drive it. Let's test drive it. Okay, so we're going to have F composite G, composite H, composite K, composite Q of X. Okay, so it's like a chain. Okay, and that's how you're going to learn that a chain rule in calculus. Okay, chain rule. That's what it makes the chain. Now we're going to compose it from inside out, G of X, H of X, K of X, Q of X, X. So many layers. Okay, you should have 5 pairs of parentheses. Okay. So now from inside out. So what is a Q? Q is the inside, right? So that's pi X. So pi X. And then we're going to apply the rule of K. Okay, what is the rule of K? The rule of K is tangent X. So this K, the input is pi X. So whatever input for K, we're going to just apply tangent rule to it. So this is going to be what? Tangent pi X. Okay, tangent pi X. We don't really need the parentheses. And H of input. So this input, if we use the function H, we just apply the rule of sine to it. So we're going to apply the sine to it. Right? And how about G? G is just taking square root, whatever input we get. So when G is applied, this is just going to be square root. Okay, you can see layer after layer, right? And last but not least is a cosine. Whatever the input, we're going to apply cosine root to it. This is the input. Therefore, we're going to apply cosine root to it. And there. And we did get the given form. So you can see this function is seen as the composition of so many simple functions, right? Cosine is basic. Square root of X is basic. Sine X is basic. Tangent X is basic. And QX is basic. I think that this lesson should is enough. Okay. If you have any more questions, okay, by the way, I will not be giving you 5 layers. Okay, the question you will encounter in this course will be just 2 layers. Okay, but the key is that you know how to decompose it. Okay, so this will lay a very good foundation for you for your calculus class. And one of the hard topics, a chain rule, is very much dependent on whether you know how to do decompose. Okay, so if you have a head start now, you're gonna earn more point. Okay, in your calculus class. So anyway, hope this helps, and thank you for watching, and until next time.